There we are. Good thing I checked it. Yeah, so I've been, let's see, I'm just going to, I always forget this stuff. Let me just open this YouTube code sandbox. Oh, it's actually there. Good thing I checked it. Yeah, so I've been, let's see. Okay. Turn on notifications. No. Block. Oh, come on. Okay. Anyways, so I've been exploring or reflecting because we have some logic at Code Sandbox related to the dev environment we're connecting to. And it's basically related to just connecting to it, which might seem simple, but it's actually quite complicated. And I've been working on this thing. Let's see, let's just branch this out. Oh, we should really fix this. It's because the branch name has already been taken. I'm not sure, this happens more often than it should. I'm just storing that image for later. Anyways, let's branch again. Let's see. So Picture Client is this thing that actually connects to the dev environment. And let's see, we don't actually need this thing running. And the way it connects is basically it first goes and grabs an instance of a VM, micro VM, and then it connects to that micro VM through WebSocket. And normally, let's see, I'm just going to create like a file here, demo.ts. So let's say you have like a connection. And what you want to express in that connection is like, is it connected? Is it connecting? Right, and then you might have a connect method, you might have a disconnect method, and you want to, let's see, what do you want to do here? Yeah, so this is okay for now. And then you want to like connect this async, and then you might have something like do something. Let's see, try this is connecting. Well, first you have to say is connected is false, and then is connecting is true, and then maybe you await something, and then you catch, and then you have to make sure that you say you're not connecting anymore. Yeah, maybe even have like an error here, which is like a string or null, and it starts as null, and then you have like an error, and then you say this dot error. Well, you don't necessarily have an error there. Maybe you just throw it. Throw error. That's perfectly fine. And this is perfectly fine, right? I don't like the fact that you're orchestrating two flags, because they're theoretically you could have true here, and that's not correct, right? That's not a valid state, but it's you have to stumble really hard to get into that scenario. But then you can start to think about things like, okay, when I connect, I might call that multiple times. So what do you do? Like, so maybe you have a check here. If is connecting, maybe you throw an error. Or maybe you don't do anything. So it will actually try to change these flags multiple times and run this something that connects multiple times. But then you might say, no, let's create like a connect promise, which is a promise of whatever or null, maybe just like this. And then you say you don't make this async, you rather say this.connectPromise equals something. And then you say, if we have a connect promise here, we'll just return that connect promise, for example. But now you have to make sure that you delete that connect promise. So like when that something is done, so I guess you would not do try catch here, you would rather do this. When that thing is done, you also have to make sure that you delete the current connect promise and stuff like that. And you could use like a you could also use like a mutex for this, like connect mutex or something like that. Connect mutex. But then again, if you did something like this, it would indeed wait for the initial connect to finish, but then you would have to figure out again, are we now connected? And if we are connected, maybe you've already returned the results of the thing you connected to or whatever. My point is really to just explain that you have to orchestrate a lot of stuff to make this kind of asynchronous logic work well. And then the question is like, is there a better way to express it? And I've been just exploring that. Yeah, maybe we can jump into it. So let's see if I can find it. Where is it? It's in, did I have it here? Or did I have it on my personal? Yeah, it's here. Because you kind of, when you deal with this kind of, oh, nice. So what did I want to say? Yeah, so what you kind of want to do is to deal with the multiple Boolean flags, you kind of want to use a concept of states instead. And then you want a kind of a mutex behavior so that you can ensure that you kind of queue up multiple methods call as you're actually like doing something async. And let's see. Yeah, and then there's but then you also want to make sure that when you do that, you don't really want to just wait for the thing that's currently asynchronously running. You kind of want to attach to the existing asynchronous flow. So, well, we can rather look at it like this. So the thing I've been working on is that you use explicit states where you say first what states are like solid states. I don't have a better word for it. It's like, what states can you end up in? So you can end up in a disconnected state, you can end up in a connected state. But then you also have these transition states, and they basically describe something asynchronous happening. And in this case, that would be connecting. And then you create this state object or state instance where it's typed so that you can only choose disconnected or connected in the initial state, because it needs to be like a solid state. And then, yeah, so that's what I also forgot to mention in the demo code, is like you typically also want to emit event. So I was connected now, I was disconnected now. So you want a sort of an event emitter logic to asynchronous flows as well. So what typically happens is like you orchestrate these flags, you orchestrate calling things while you're running asynchronous code, and then you're also orchestrating the event emitting. But in this case, this state instance is an event emitter. So you can just say, if you want to expose the changes to the state, you can just expose that. So that will be on transition. And then what you do whenever you implement a method, you wait for that state to resolve. So that means that if the state is currently like transitioning, in this case connecting, it will wait until it lands in either disconnected or connected. So that's what you're doing here. You're resolving the state. It can only result in disconnected or connected. And then you check if it's disconnected, you start a transition. And that transition uses the state connecting. And this is all typed. You can only use connecting here. And then it expects you to return one or multiple, one of the solid states. What's solid? Not sure why I'm using that term, but yeah. And then it runs that transition, and this produces a new state that might be connected or disconnected. And then finally, we check if we are connected, and if we are, we return a connection, and if we're not, we actually throw an error. So what would happen here if you ran connect multiple times during the transition is that it will always wait for the current thing to resolve. So if you call the first time and we are indeed disconnected, it will check that, it starts the transition, and then you make a second call to connect. Now it will wait for that transition to resolve before it moves any further. So that means if it ended up in disconnected, the first call would like throw an error because it went down here, but the second call will now see that it's disconnected and will actually try to connect again. And then if you had like a third call, as you did the first call and it made the transition, if you clicked like twice on something and it connected twice, then the third call would actually wait for the second transition before it ran the same logic. And the point is that it would typically be connected and it would just return the same promise with the same connection, and it would just resolve itself. The point is that you shouldn't really think about this. You should just think about it as, okay, I'm just going to resolve the current state, and what do I do with that state? And then it doesn't matter how many times this logic is called, it does what you expect it to do. Like each call is resolved by itself, and it never like over calls, like over connects in this case. What the hell just happened here? Oh, did I do something wrong in documentation? Oh, maybe I did something wrong here. What the hell? What the hell did I document here? Oh, I think I was... What the hell? This is weird. Did I actually commit this? Did I actually commit this? That is indeed weird. I have no idea why this is here. Because what we would do, yeah, maybe we can just fix this. So what if I wanted to disconnect? Is it, oh my god. There's, wow, that's weird. Async disconnect. Weird. It's so sad about the syntax highlighting here. Oh, is it because it's missing? No. Oh, that's so sad. Yeah, I'm not sure why. Nothing. That's weird. Like it shows the thing. Yeah, I guess we don't have that great of a syntax highlighter for Markdown. Anyways, so you would do the same here. Like you want to do something related to the state. Wait, this state resolve. So you just wait for it, and then if status equals disconnected. Connected. then you would take the connection and you would, for example, dispose of it. And you can safely, let's see, dispose, and then you can say this state set status disconnected. And in this case, we're not actually checking if the disposal works. Like, that's possible. Like, you can try to disconnect and it doesn't disconnect and you're still connected. In this case, it's completely ignored. But you could choose to deal with that. So you could have like a disconnecting transition state and basically do the same thing. But yeah, so again, if you click disconnect multiple times, it doesn't try to dispose of anything multiple times. It just checks. It waits for it to resolve. And in this case, if you were, for example, clicking connect, it is transitioning to connected, for example, and you would click disconnect as it was resolving to a connected state, it would actually just wait for that. And then you would be connected. And even if you click disconnect multiple times, it would only deal with it the first time it moved to connected, because it immediately moves to disconnected. So this is the thing with the resolver, is that first of all, it waits for any transition to resolve. And synchronously after you've done that, it's safe to change the state. And it's typed correctly. So you can't like set the state to connecting. You have to do a transition to do that. That said, like, let's commit this. You can easily argue that this is like adding API and you have to learn something to deal with this, as opposed to just dealing with Boolean flags and promises and like simple event emitters and stuff like that. You kind of have to learn something new. But that's the case with like mutexes as well. Like, you have to understand how they work. But yeah, anyways, so let's remove that thing. And then we'll rather go in here. I don't really have that much time, but yeah, let's play around with it. So I think it's like 1.1. It's 1.1.1 or 1.1.0. I can't remember. Oh, 1.1.2. Okay, so let's install dependencies. And then we can, so the thing is, I changed the API surface to simplify it. So it already uses class states to manage this, but I think I over-engineered it. Because you really just want to work with the state. That's the thing. You just want the state, and then you want to check it, and then you want to do something. While the previous implementation, it was difficult to understand, like, where do I set the state for the transitions and so on and so on. Well, now it's much more natural. Where is the... Oh, there it is. Oh, what happened here? Oh yeah, now it breaks because I changed. That's perfectly fine. Let's just close this. Wait, did it start 2 of them? Oh no, it started the build task after install. So yeah, great. Now it's wrong. So we have the WebSocket connection here. So what we can do is we can say WebSocket transition state. That will be connecting. And as you can see here, I'm manually adding this transition. So it's not like part of the API to even think transitions, but it's conceptually always part of it. So we don't even need to define what it resolves to. That's just part of the thing. Yeah, and sorry, I'm using status instead of state. And then we say status disconnected. Cool. So this is what the WebSocket can do. It can be in a disconnected or connected state. And then we can trigger a transition, which is connecting. So what we want to do here is okay, so emit message. This is every time we get a message. So what we can choose to do here is we can say state this state. We can just say get. Now this state status, it can be any of them because this is the raw state. So what we could do here, we could say resolve, and that will be a promise of WebSocket state, which is connected or disconnected. But the thing is, emitting these messages, we don't really want that to be an asynchronous operation. So we just want to immediately do it. So here we can just check if status equals connected. So this matcher is kind of cool, but it doesn't really help that much. You see, it just simplifies and make things more straightforward. Like sometimes API abstractions are super valuable. Other times, when there's a learning curve to the abstraction, then you really have to evaluate if it's necessary. Sometimes it's just better to not create abstraction, and maybe you'll have to write a bit more code. So like the matcher in this case added code, but normally it will reduce code compared to doing a switch statement. But switch statements are really good in terms of typing and evaluating that you're dealing with the different scenarios and stuff. So anyways, so yeah, so this is interesting. So this is where we actually connect. And what we want to do here is, let's first put this into a transition, into a connecting. Let's see, what the hell am I doing here? Okay, I'm going to write this again. So this is the thing that actually does the connection. So we're going to return this state transition. Sorry, status connecting. And then the callback is the actual connecting. The thing is that it's not a promise that resolves the connection. It's like an event from the WebSocket. So I was thinking, okay, let's first just return a promise. And then look at the code. Because the thing here is that let's see. Where's the open? Yeah, so here we have the open listener, but we don't really want to set the state. What we want to do, we want to resolve this promise and say we are connected. The problem is that this is an event, so you could argue that this could happen multiple times. Open, you might like, I don't know if you can like reopen the WebSocket connection, or you will actually create a new WebSocket connection. But but let's see. This should be a promise of WebSocket state at least. We resolve that. So the challenging thing here is that it's registering these listeners. So for example, when it, yeah, I just can't remember if, do we dispose of the WebSocket when it disconnects? Well, I guess we do. And then we create a new WebSocket whenever we connect again. Yeah. Yeah. Okay. Anyways, so the point is that this should always resolve, because it either resolves to a connected state or a disconnected state. So yeah, so the challenge is that, okay, what if it resolves to a disconnected state when you initially try to connect and you resolve to that? That's fine, but then it might resolve to connected. That resolves the promise, and then later it's disconnected, and then you try to resolve it to disconnected again. So dealing with events to evaluate like the initial state of something is surprisingly tricky. But now I'm refactoring this, and I'm trying to reflect on how would I write this if I already had this API. I would probably split this up into 2 steps, so that if I had like the initial promise would be like just the logic for making the initial connection. And then if I made the initial connection, then I would register all the listeners for dealing with that open connection. And then I wouldn't bother if it errored. So maybe we could try that. So yeah, because then you wouldn't even have an open listener related to. Yeah, and you wouldn't start a heartbeat or anything. Yeah, that's interesting. Okay, so I'm gonna try to split this up. So what if I rather just create a new promise? And this promise will resolve or reject with a WebSocket connection. That's all I need. It's the WebSocket connection. So it creates the WebSocket, resolve. Yeah, I didn't time box this very well. And what we need to do, we need to check where are the event listeners. So we only care about it opening. If it's open, we're going to do resolve vs, and then vs add event listener close reject. There's probably some event. Okay, let's throw the event. Yeah, let's just throw the event or reject the event. Let's see, reject. Does this actually give you the WebSocket? It gives the target, event target. anyways, so this is the only thing I really care about. Open. How do I do this? Actually connect to the thing. Isn't that? Does that happen? Oh, creating the instance actually connects it. Okay, fine. Okay, so the point is that now I created a promise that's only concerned about creating the initial connection. And then I have my WebSocket here. So now I can actually remove this. I can remove, where is it? On open. Well, let's remove this. I do wonder though. Yeah, wait, this won't work. Because if it's, yeah, and this is what I mean. Like, we need these listeners to be, yeah, this is. Yeah, it's really horrible. Like how you make a WebSocket connection a promise. Because we have to dispose of these listeners. Like the open, we don't really have to dispose. But close, we have to dispose so it doesn't try to reject the promise later when it does close. And the same, yeah, it's super annoying. I kind of have to do. Yeah, this is really annoying. Like the good thing is that you scope the initial connection to one piece of logic and don't mix it with all the logic related to actually having a connection. But still, it's like horrible. So you kind of have to say remove event listener, close. And then you resolve it. Yeah, so we can just do this. And of course we can like remove. Oh, remove all listeners. I didn't know. Huh. But yeah, this will be the proper way to do it. And then we can move this stuff up. Oh my god, there's so much red. Yeah, and then we also have to, yeah, I'm not sure I like this, but anyways. Disconnected. Yeah, and this would actually be the event, like the error event. Well, we don't really know that. Yeah. Oh my god. I wonder if there's like a library for that. Yeah, they use on error, not on close. But this is wrong, right? Because you it might get an error after it's open, so this wouldn't work. Yeah, one shot device. It's interesting. Yeah, you know, I have to stop soon. This wasn't the stream I was hoping for, to be honest. But yeah, no matter. It's some things for reflection, both in terms of like how you express these connection states, basically any asynchronous flow where you have certain states that are like solid, some of them are transitions. How do you orchestrate that just using plain TypeScript or JavaScript? And then how do you actually make a WebSocket connection a promise? It's fascinating. But this is really the right way to do it. But I wish I had. Maybe we can try to finish this just to see how it looks. So yeah, but the thing is, I really want to throw the rejection here. But you know what I can do? I can say like code -1, and I can say reason. So I can say reason in event.reason. But I probably have to check, like, is this a string? And like I can't know 100% that this is an actual WebSocket event. So I will kind of have to create like an error, like an instance of an error that reflects that it's sometimes it's just how do you even WebSocket detect fail connect? Oh, it's actually on error. On close, yeah. Yeah. No, it's on close. Yeah, I wouldn't expect it to be on close. But anyways, let me just write a reason here. So the reason is and then was clean and it's false. Okay, so now at least we have an error to connect initially. We just return disconnected, and then we have this thing which should like return a status of connected. Why isn't this typed? Oh yeah, exactly. Oh yeah, sorry. So this shouldn't be. And this is also a thing with promises, which is really bad. Like I want this to be WebSocket state, but then this is WebSocket state, but I don't want that thing to be WebSocket state. This should be WebSocket. Yeah, I guess yeah, this is tricky. So I guess I have to say promise of WebSocket state here. And does it understand it now? No, it still thinks it should be. How the hell do you express that? Like you have a promise that starts with one value, but you expect it to return a different value. Like, how the hell do you do that? So I want this promise to be a promise of a WebSocket, but I want this thing to actually like, of course I can explicitly type it, but it doesn't feel right. Because I want to express that like this one and the catch should result in, well, I guess I will get an error if, yeah, so the catch was actually typed, and then, yeah, I guess I kind of have to do this. Yeah. And then this would be connected. And I think it takes dispose vs. What else does it? Yeah, and the WebSocket. Oops. Oh yeah. There you go. Okay, well that's fine. That makes sense. Anyways, so we have on our on message. Okay, so here we have the on open, but now we actually are open. So we can just run the heartbeat instantly. So we can probably, where's the on heartbeat interval? Nice, so we can do, yeah, we can even do this. Okay, we're getting somewhere. So this should not resolve. So this is another interesting one. So we might try to dispose of the WebSocket. So you get some event or some error state that triggers this. It could be like the error event. It could be us trying to send a message, which fails. And that could be, this could happen during a transition. Maybe it fails because you reconnected and it's still in the connecting state and you try to send a message. Yeah, and that's interesting. I don't think this logic that I put down here, this should probably be part of dispose vs. So if it's connecting, then we don't do the disposal. Yeah, the question is like, would we just set the state? Or would we do state equals this state result? And it will be async. Like, what would happen then? Like, is there a scenario where you could be connecting and we're trying to dispose? Like, the point is that that's the thing about asynchronous logic. That's why you get race condition, is because you never, you create flows for what you expect to happen, like the happy path. And then suddenly some event triggers you didn't consider. So that's kind of, you can look at this in two ways. You can look at it as, this complicated things, but it doesn't complicate things. It exposes the complexity that's already there. The question though is, when we resolve this state, if it resolves to connected, we don't know if it's connected because it was reconnecting and connected, or if it or it was already connected. So I think what you would want to do here, you would just want to go and grab the current state, and then you would just, if the state is actually connected, then you disconnect. Yeah. That's like the proper way to handle it, because you can never be yes, I would say we even put all of this stuff in here. So if we really are connected, like we can't guarantee that these events actually happen. Yeah, it's super, super tricky. Like if you really just dive into all the like possible race conditions and yeah, no, I have to go. Yeah, no, I have to go. Bye bye.